Okay, hi, thanks for coming. So my name is Christophe. We're going to be talking about misconfigurations in OpenID Connect in cloud environments and how we can abuse them. So a bit of introduction. The context is this one. You have, some CI pipelines, some Terraform pipelines that you want to deploy into one cloud. And typically, the way you're going to do this is you have hard-coded credentials in your pipeline, right? You put that into your in your GitHub Action configuration, things like that. And the main issue with that we've realized is that this is terribly insecure because the credentials stay valid for, an unlimited period of time. And so there are better ways now. And namely, what is recommended in something like this, where you use the identity that the CI platform provides you. So typically, if you use GitHub Actions, GitLab CI, Azure DevOps, Travis CI, they give you a JSON Web Token that you can use to give to AWS and authenticate this way. And what we're going to see today is what can go wrong in this configuration. And namely, we were able to find some bad stuff in the UK government environment. And we got this nice medal home, which was a very nice Christmas gift. I'm Christophe. I work at Datadog, which is a French and US company. I'm French. I live in Switzerland, and previously I've worked at Hacknowledge and NextThink, where I've done some mostly cloud security, open source, and container security as well. Cool. So there's going to be a bit of introduction, and I want this talk to be useful, even if you don't care about the mesh configuration aspect. So we're going to have a bit of IAM fundamentals in AWS. To poll a little bit, how many people are, using AWS or are familiar with AWS? Quite a lot. Who has never used it before or never seen anything about it? Some people as well. So hopefully it should be useful to most people. We're going to see also how you can set up OpenID Connect in CI/CD environments. So hopefully this will be practical. And then we'll dive into the offensive and misconfigurations aspects of it. So before we dive into AWS, outside AWS, the concepts of role, typically it means you have a set of permissions that you want to assign indirectly, right? So maybe you have a security engineer role, and you want everyone with the same role to have the same permissions. So it's a way to assign permissions indirectly. In AWS, it's totally different, so you have to forget about all of this and consider that a role means something totally different. Namely, it's a full type of identity that you can authenticate as. In AWS, you have two ways to authenticate IAM users and IAM roles. So a role is not a way to assign permissions to something. It's a full entity by itself. Something to keep in mind. So IAM users are pretty simple. You have your username, your password that you can use to authenticate to the UI, to the AWS console. You have your access key, which is the programmatic API key that you can use to use the AWS API, CLIs, Terraform, things like that. So if you want to use the UI, you just use your username, your password. If you want to use the CLI, you just export in your environment your access keys, and you can use the CLI, Terraform, things like that. Now, the main issue with that is that these credentials never expire. So if you created something 15 years ago, it's still going to be valid today. And in practice, it means that we see a lot of breaches that are caused by these. Namely, if you look on GitHub, you will find some keys. If you look in configuration files, things like that, you will find some access keys. And actually, when you look at it, there is a lot of data that supports that. So this is a study from Git Guardian. They say from every 10K commits, they find 84 AWS, specifically AWS keys. This is a paper from 2023 that scanned all the container images, and they found also a bunch of secrets, including AWS keys and Azure keys, things like that, inside the container images. So it's also a research that I did a few years ago. So looking at, sorry for that, but looking at all the cloud breaches and trying to figure out what is the cause, you see that most of the time it's someone that committed an access key in GitHub, something like that. So it's really the top one concern for cloud security professionals today, for most of them at least. And so the solution is not magic, but it's mostly called IAM roles, and you can think of it as a credentials vending machine. So you ask, hey, I want credentials for this role, and you get back some credentials that are valid for up to 12 hours. So you are here on the left, and you say, I want some credentials. The name for this is assume the role. You want to assume this role. You get back some credentials that are going to be valid for up to 12 hours. The way it works with the CLI is like this. You say, I want to use this role. You give the AWS account ID here, the name of the role here, and you get back some credentials that similarly to the IAM user, you can put in your environment and use the CLI or Terraform or anything. Now, the question is, how do you authenticate that, right? Because if I tell you not to use IAM users, you still need to bootstrap your identity. You need to start somewhere. So there are different ways that you can start to have an identity that you can then use to assume this role. And there are two main cases. If you are already inside AWS, which is the easy case, so you can say, I want to assign this role to an EC2 VM, to a Lambda function, and then it works magically because you're inside AWS. You can also say, I want this specific role to be able to assume this role. But that's the easy case. Here we are outside of AWS, so we need one of these two things, a SAML identity provider, mostly for humans, or an OpenID Connect provider, mostly for machines. And this works, like, it's quite simple. As a human, you're going to go to your Azure ID, your Okta, your Google Workspace, you authenticate, you get back typically a SAML assertion, you will give that to AWS, and if you configured your role properly, you get back some time-bound credentials that you can then use as we've seen. Now, I want to dive a little bit into the use case specifically for CI/CD pipelines and how you can do this flow with OpenID Connect. We're going to see first the manual way, and then how you typically use that doesn't have all these details. So, again, this is what we don't want, okay? You have your pipeline, you don't want the long-lived IAM user access keys because they are going to leak and things are going to go bad. So we want this. Again, the idea is that if we leak something, it's going to be valid for 12 hours. So the risk is going to be for 12 hours, not for 12 years. We have found some keys that were valid, since 15 years. So I can tell you. So the way that you're going to configure your role is something like that. And again, this JSON Web Token is something that automatically is provided by your CI platform, whether it's GitHub Actions, Travis CI, GitLab CI, they do that. So how to configure your role? So this is the trust policy of your role. It defines who can assume this role, who can get credentials for this role. And there are a few things here. The first one, this defines the identity provider that you need to trust. So AWS is going to take the public key from this URL to verify the JSON Web Token. And this is the condition on the JSON Web Token subject. And here we say, I want that any CI pipeline within the Datadog/myrepo GitHub repository on the main branch can take this role. Now, when you're inside the pipeline, the manual steps to get this JSON Web Token is to do that. So this is basically a curl command that returns the JSON Web Token. If you decode it, you will see it contains the subject. So it's basically an attestation by GitHub Actions that says, I confirm that this is coming from this specific pipeline on this specific branch. And you can see that the issuer is this one. So if you open this URL, you will actually see the public key that the JWT can be verified with. And then you can just pass this to AWS using assume role with web identity. So you pass the ARN of the role, which is the Amazon resource name, that contains the account ID and the role name, and you get back some credentials again. Now, these are the manual steps. In practice, typically you do something like this. It's a pre-configured GitHub action where you just give the ARN of the role that you want, and it will do all these steps automatically. So really using OIDC in CI pipelines is much easier and much more secure. This works also for Azure, for Google Cloud. So that's the how to do it properly aspect. Now, what can go wrong? Obviously, otherwise I wouldn't be here talking. So what can go wrong? A few things. So if we start from the right condition, okay, it's something that looks like this. Again, you're saying any pipeline in my Datadog/myrepo repository in the main branch can take this role. What can go wrong? So the first thing that is not ideal is you can say any branch can take this role. It's probably not as good. Maybe you don't want your dev branch to be able to deploy to prod, but it's probably not that bad. If you do that, it gets a bit more tricky because you say any repository in my organization can do that. It's not terrible, but it's not great either. And if you do the mistake of forgetting this slash, things go bad because anyone can create, a repo that is named with your prefix and assume your role. Similarly, if you just use a star or if you just omit the condition, it means that any GitHub action on the world that anybody creates can assume this role and get some credentials in the AWS account, which is typically bad because these roles are typically privileged, right? We all have this CI/CD role that is privileged and that, you don't really know how to strip the permissions off. So how can we hunt for these at scale? And the idea is, right, to first try to find some roles that we can try to see if they are vulnerable, get some credentials in the AWS account, and see what we can do there. So how to search for role arms? So nicely, it's a piece of data that is not considered sensitive because it's just the AWS account ID and the role name. So typically, you can find it in public GitHub repos because that's by design. So if you also look at build logs, things like that, you will find some. This is an example with a source graph. If you search with a regex, you will find a bunch of role arms that look like this. The idea then is to create our own GitHub actions. So again, I'm the attacker. I create my own GitHub action. I just need this configuration. I run this curl command that I described before, which is going to give me the JSON web token. And I just, again, I use this flow. I use STS assume role with web identity. And you see if you get some credentials back. Spoiler alert, we did find some vulnerable roles, dozens of them, actually, mostly for a few reasons. One of them being that there are some online tutorials that give you the wrong steps on how to configure your role. And so, this is what you get. So typically you say, I'm testing this role, and you see that you get back some credentials that prove that this role, is vulnerable. We reported that responsibly. Sometimes it's hard because sometimes you find a role that belongs to someone individually on GitHub. They don't have, they don't put their name, their email, so you don't really know who it is. Sometimes it's a company, and it's very hard to reach out to them because they don't have specific guidelines, and sometimes it's very easy. I want to stop a bit on one specific example that was quite a nice surprise. So we found this role that we managed to get some credentials for, meaning it was misconfigured. And when we searched for it, so we just searched for that string on GitHub, this is what we found. So, Gov UK infrastructure, Terraform automation for the Kubernetes cluster that hosts gov.uk. So this is quite interesting. Obviously, it's the UK government, specifically the branch called the Government Digital Services, GDS. And if we look at how this is used in the pipeline, they actually use AWS code commit, which is an AWS service similar to GitHub, where you can push and pull Git repos. So the next question is, what can we do with that? So we found in one of the readmes this piece of Markdown that says, hey, we have this private repo. I'm not sure what they mention it, but anyway, so what we try to do is, well, let's try to clone that, obviously. And with the credentials that we compromised, we were indeed able to clone this repo, which sounds interesting because it's called Gov UK AWS data. So obviously it's like quite interesting. And, we were able to clone it. And the nice thing, is that the role had these permissions. So the git pull allowed us to pull this repo, and the git push would have allowed us to push basically malicious infrastructure to this repo. We reported that on HackerOne. So again, it's very nice because they have some reporting guidelines. And when you report something to a government, you want to be sure that you don't need to hire a lawyer for it. So it's nice to have a process, like a paved road for that. The issue was fixed in 26 hours, which is pretty good. It's a pretty good surprise. And the contact with them was really good. So if you ever find something in the UK government's websites, do report it. It's definitely worth it. Now, I want to look at a bit at the root cause for this specific issue. If you look at how the role was configured, this is the trust policy that you will find. And to me, at least, I stared at this for way too long. And to me, it looks secure. You have here, the condition on the GWP subject. You have here, it should only be for the AlphaGov UK infrastructure repo on the main branch. And here you have something for the GWP audience. So to me, it looks secure, but for some reason it's insecure. Anyone can see what's wrong here? Okay, it took me 2 hours, so I'm not going to blame you. But what's wrong is that you have some duplicate map keys. And this is defined using the HashiCorp language, so the HCL in Terraform. And the way it behaves is that it's basically undefined behavior. And in this case, it just basically does that. So the policy, even if it looks fine, actually what it does in practice is that. So specifically when the HTML parser parses it, this is what you end up having as JSON. So that's why there was an issue. And actually, HashiCorp, but maybe we should call IBM HashiCorp now, but there is something called HCSec 2023-26 that says, basically, we are aware of this. It's not great, but we cannot fix it because it would have a lot of impacts that we are not sure what they will be. But they did try to make things better. So in version 5.19 of the AWS provider for Terraform, they added a check that if you have duplicate JSON keys in your policies, they will block it. But that's assuming that you get to the JSON stage. In our case, this was at the HTML stage. So it can help, but not always. AWS also sent an email to their customers. So if you had a vulnerable role, you got an email from AWS probably in early September. And when you try to create a role that's vulnerable, you will get this cryptic error message. You probably don't know what it means. It's very hard to read, but at least it's going to get blocked. So this is great. It's much better when you are creating new infrastructure, but it's not foolproof. Typically, if you use this vulnerable condition in your policy, it's not going to block it. So it will block the star, but not a repo star. So it helps, but again, you can see how this is still going to be wrong sometimes. And again, all the roles that were created, so from 2021, when this feature was introduced, to mid-2023, if they were vulnerable, they are still vulnerable, nothing is going to magically fix them. Now, a few practical tips. I want to first look at, if you're a defender, a security engineer, what you can do, and more if you're on the pen testing side, some opportunities. So for defenders, I think the main takeaways is you're sitting in a talk saying that this is insecure, but please use it because it's actually much better than the alternative. So it's actually much easier to configure. It's more secure because you don't have long-lived credentials. You don't have to create IAM users and then deprovision them. So it's really more secure, more convenient. So I would really encourage you to have a look at it. It works for Azure as well, for Google Cloud as well, and it works with most of the CI platforms. I will post the slides online, but with this ugly one-liner, you can check if you have some roles that are using GitHub Actions, even if they are not vulnerable. So this will give you the list of roles that are assumable by GitHub Action, and then you can have a look at the trust policies to check if something looks off. But also this tool by Resonate, which will look at your role and analyze the trust policies to find if something is vulnerable. If you are lucky and you use GitHub Enterprise Cloud, you also can use a specific GWT issuer for your GWTs in your pipelines, which look like this. And the impact is that this will have a different signing key that the OIDC provider from other organizations. So even if you mess up your trust policy, anyone in your organization can assume the role, but not everyone publicly, which is a really good guardrail. So if you are using GitHub Enterprise Cloud, it's like a quick win. In terms of detection, you can also look at CloudTrail logs. So CloudTrail is the way that AWS logs all the events that happen on the AWS control plane. And one of them is assume role with web identity. And we see here that it has the GWT username, so the subject, and the role that was assumed. So if you look at these events and you exclude everything that comes from your organization, you will find if anyone has tried or successfully assumed one of your roles. And this is typically what you would use if you want to do it tactically. CloudTrail SQL Lake is the way that you can use basically SQL to create CloudTrail inside AWS. For pen testers, so I think it's a great opportunity. If your target is using GitHub Actions, there are some attack vectors. One of them is this one. There are also some vectors for pull requests. So typically, in many cases, you are able to open a pull request and modify the CI pipeline to do malicious stuff. And this will run in the context of your pull request. So these are some good opportunities. Sometimes you don't have the role ARN, right? You don't know the AWS account ID or the role names. So there are a few options there. First one, that is actually quite a recent find from the community, is that if I give you any S3 bucket, whether it's public or private, you can actually find the account ID that it belongs to. It's a bit of a messed up way, but there are some tools to automate it. And since S3 bucket names are everywhere, So you will see them, in CNAME responses in DNS. In the JavaScript code, you have some tools that will scrape the whole website and give you all the S3 buckets that it finds. It's quite easy to find an account ID if your target uses AWS. Something else is that you can actually have an oracle in the sense that it will tell you yes or no to find if a specific role with a specific name exists in a specific account. Again, it's a bit of a messed up way, but there are some tools. And basically, you could try to say, does the role GitHub Actions exist in this specific account? Yes, no. And then try to assume them to see if it's vulnerable. So obviously, you would have to use a word list for that. But if you look online, you will see that many of the roles have the same name because they are coming from tutorials or from modules. So it's quite realistic. So to conclude, and I think we're a bit early, but that's fine. More time for coffee. So the same thing works for Azure AD and Google Cloud. Okay, so in Azure AD, it's called federated credentials. If you open the app registrations page, so this is basically like the service accounts. In each of your app registrations, we have this tab called federated credentials, where you can do exactly the same, and then you have an Azure API call to exchange a GWT for Azure credentials. For Google Cloud, it's called workload identity federation. Same thing, same misconfiguration, same attack vectors. So if you're a researcher or if you have too much time on your hands, I would really encourage to try to do similar things for Azure, for GCP, because there are some opportunities there. In conclusion, by all means, use OIDC in your CI/CD pipelines because it's easier and more secure. Just be careful, but again, it's better than actually using hard-coded keys. And finally, there are quite a number of roles that remain vulnerable and that are yet to be found. So if you're looking for new ways to do bug bounties, I think this is a great one because it's not very well explored yet. I also put some literature here because there was quite a lot of research on the topic. One from Tinder, the one from Resonate was actually released the same day as ours, and they talk about GCP and AWS. And finally, the last one is from Scott Piper, and he takes this whole story and he shows how like different companies and different people have, as a whole, made things a bit better in the community. So it's a great read as well. Thanks a lot. The slides are here. If you have some feedback, some things to improve, please leave it, and please feel free to write me or to follow me. Thank you. Any questions? You can also come afterwards. Whoa.
Yes. You didn't talk about client assertion and that are GWT-based token to authenticate apps that can also rely on public keys that are exposed on secure endpoints. Could it not be a good solution also to avoid key leaks in codes, etc.?
So you said SAML assertion? I'm not sure. I got the word.
The client assertion for OIDC, that is an alternate way to authenticate apps instead of client secrets that can leak in code.
I'm not sure if it's supported by like these CI/CD providers. It's probably a good way for like standard apps. I'm not sure how it plays out for CI things like GitHub Actions, to be frank. But I can check it out. Thanks. Okay, thank you.